skeletal system is comprised of the following parts, some of which we won't spend a lot of time on. Skeletal system, excuse me about that, is composed of bones. The connection of bones, a lot of people think of joints as like a thing, but really it's the connections of bones. Also in a joint is ligaments, cartilage. Here's a term that people get confused a lot. Ligaments join bones together. And we'll take a look in class at a couple things that'll help you remember that probably. The skeletal system's organs are bones, ligaments, and cartilage. Ligaments are technically connective tissue, and so is cartilage. A bone is an organ, and we'll talk about why. Even though it's made of bone tissue, the whole bone itself is an organ. And then, of course, joints where two bones come together. The functions of the skeletal system, there are 5. Here's a skeleton with some of the parts you'll need to know. Number 1 is for muscles to attach and help it move. Number 2 gives you your shape and structure. Much of what you look like is determined by your skeleton. Of course, you add fat and muscle and things like that, but if you think about the structure of somebody's face, the structure of their, the width of their shoulders, their hips, how tall they are, this is pretty much determined by your skeleton. And number 3, protection. This is the one most people think of right away when they're thinking about what some functions of the skeleton are. Protect internal organs. You'll notice that the important organs are all very well protected. Okay, your chest and your heart and lungs are protected by this cage of flexible bones. Your brain is protected by a non-flexible cage of bone. One of the functions to make red blood cells, and we've talked about this a little bit before. The stem cells for red blood cells are found in the bone marrow, and that could also, actually we probably should just say blood cells, because white blood cells called B cells are also made in the bone marrow. And the last one, and the one people forget a lot, is the job of the skeleton is to store minerals like calcium and phosphorus are stored in the bones for use later, and we'll talk later on about what calcium and phosphorus are used for in the body. Bones there are varied kinds of bones. The one we're going to talk about is a long bone. There are also irregular bones, flat bones. Flat bones would be like in the pelvis. The sternum is a flat bone. Okay, irregular bones like your vertebrae. If we talk about long bones, the ends of the long bone is called the epiphysis. And they're made of something called spongy bone with lots of struts, arches. It's not really spongy, but it looks spongy. The middle of the bone, also called the diaphysis, is what's called compact bone. It's very hard, very dense bone tissue. Also, what you find a lot in bones are canals. Haversian canals and Volkmann's canals, that's the names of them. And if you think for a minute, why would bones have canals in them? Well, you have to be able to get blood vessels and nerves in and out of the bone. And you're like, well, why do I got to get nerves? Bones don't really feel any pain. Well, they do. If you've ever broken a bone, you know that. But we'll take a look at a skull, and you'll see lots of openings in the skull for nerves to pass through and around through the bones to get to parts of your face and things like that. Also, if bone marrow is making blood cells, there has to be a way for blood to get out. And so you need blood vessels to go in there. And we have on the next slide is a very blown up picture of the inside of a compact bone with these canals running through it for blood vessels and nerves, blood vessels coming in, and then just a quick view of what the inside of a bone would look like if you could see it. Bone growth. This is a fetal skull. We'll talk a little bit more about long bone growth in a bit. The bones develop from hyaline cartilage in the long bones. and from membranes in the flat bones, such as the skull here. Here's a fetal skull, and there are the major bones of the skull develop as such. They start out as a membrane, and bone is deposited in an outward fashion, like so, from the ossification center out. And so this fetus is stopped. It's because this fetus was aborted. It stopped growing bone outward in such a fashion. If the fetus would have been born, it would have been born with a soft spot here where the bones aren't all fused together yet. And there's a really interesting reason for that, and I'll let you think about that, and we'll talk about it in class a bit. So anyway, bones in the hands, feet, and the skull are not fully formed until up to 5 years after birth. Not up to 5 years after birth. And then after puberty, of course, the bones aren't ever really fully developed until you're done growing. And that happens after puberty. We'll talk about that in a second. So here's a picture from your textbook about bone growth. And what you need to understand is that bones grow from a model of hyaline cartilage. Okay, so we're talking about an embryo. So this baby or embryo is less than 3 months old, and the first thing you see in an arm bud, for example, is hyaline cartilage. And then in the middle of that is bone starting to be deposited and laid down and replacing cartilage. In a fetus of 6 months old, or 6 months to 3 months, there's actually 2 deposition centers for bone, 2 on the outside in the epiphysis, and 1 in the diaphysis. And this one is producing compact bone, and these guys are producing spongy bone. Now, after you're born, what's happened is the bone is fully grown to the ends, and fully grown here, not fully grown, but at least has grown here. And then between is what's called the epiphyseal plate or growth plate. And it's that growth plate that's still cartilage. And as you're growing, both sides of the cartilage are laying down bone. So this cartilage is making bone here and making bone here, and the bone is growing longer. It also deposits bone. Bone is also deposited on the outside of the bone to make it wider. What we don't understand is how this happens pretty much all at once throughout your body, but it does. And the influences of human growth hormone and other things we sort of understand, but not to the greatest extent. The other thing to note about bones is that bones are always being remodeled. Bones are constantly changing due to stresses. This doesn't mean stress like, oh, I'm so stressed, but stress is on them. And calcium levels in your body. So for example, if you're lifting a lot of weights, your bones will get stronger where your muscles attach. And that means they'll get thicker. And so this side of the slide is talking about just bones growing, how cartilage grows and bone is laid down, and bone is laid down and cartilage grows. But on this side it's talking about remodeling, where if this is a bone, okay, and you're lifting weights and the muscle's pulling on this bone a lot, it's going to get thicker there. The bone is actually going to grow. In some places then, though, where you're not using bone so much, it may be worn away a little bit. Okay, this happens a lot. Astronauts going to space, and one of the things they worry about is their bones losing their density, because they're in no zero gravity, so their bones lose their essential density because bone gets resorbed by the body. The calcium is used for things and not replaced, because it doesn't need to be. So a hormone called parathyroid hormone or parathormone stimulates things called osteoblasts. Osteoblasts are bone-laying cells that lay down bone. And when those osteoblasts get trapped, they convert to regular bone, and I'll show you this in a minute. Okay, so on here there's like literally bone growing cells laying down bone. Osteoclasts are cells that eat away bone where it's not needed anymore. So in an astronaut, the osteoclasts are doing way much more work than the osteoblasts. So on this hyperlink here, as the quiescent phase means the phase where it's not growing, here's osteoclasts ate away the bone, okay, and then osteoblasts produce more bone, here called cement line, and as this bone gets covered up down here, it becomes bone, and the osteoblasts move that way, essentially. Okay, the last part of this is on fracture repair. And on this slide, just a couple of things to point out. First of all, here's a broken humerus. You see the green stick fracture nature of it. Here are the pins and plate that were put in to help that heal. On this side, you see a diagram of a knee joint. And you can see right here where the arrow is, or I'll put a line on it, the growth plate. Okay, where the bone is not yet formed. We'll talk a little bit later about how x-rays work in class. You can see the growth plate on here. This is an MRI. An MRI of a knee joint, not only do you see the the femur here and the tibia down here, but you can also see in the black ligaments and tendons that are holding the knee joint together. And that's why they do soft tissue. For soft tissue, they'll do MRIs. But anyway, in a fracture repair, any break in a bone is called a fracture. Okay, so you might hear somebody say, well, do you have a fracture or do you have a broken bone? Well, they're the same. A fracture is the same. In here, what will happen first is the bone breaks and you get this inflammatory response we'll talk about later. And the outside of the bone, the tissue grows back over it and traps inside this bloody hematoma, is basically a blood clot. And then as the blood is there kind of in the middle of the bone, what happens is you start getting new blood vessels forming through here. And you start getting what's spongy bone trabecula, or pieces of spongy bone are laid down in there. Now this happens where you have compact bone too. And then as time goes on, okay, remember now the whole time takes about 6 weeks. You really can't speed this process up by drinking a lot of milk or anything. So it takes time to regrow blood vessels and things like that. You form what's called a bony callus. A callus is any spot in the body where you get more tissue than you had before, essentially, or more stuff. And so you have this bony callus of spongy bone. And the spongy bone, of course, is easy to produce because you get this sort of interlinking network. And then after time, that fills in with compact bone. Okay, so you get this, and of course, you see that it's swollen here. Okay, your body's reaction to a stress is to lay down more than you need. And then, over time, osteoclasts will wear that away and make it smooth again.